Okay, we managed to begin. Perfect. Okay, so we are now, finally, I would say, at the closing ceremony. Now there will be the problem analysis, I will do some thank you talks, and then we'll have the big reveal of who won. But before that, some of you may have noticed that I didn't do this year at the opening ceremony my grand entrance with the trophy. And the reason is that, unfortunately, the trophy is very much broken. And so, we managed to get another one in time. Okay, I don't want to bother you too much. I will do that later. But so we can start, I ask, while I talk a little bit more, I ask Nikki to come to put the right slides on. I don't know if he missed the cue. It will arrive eventually. And thank you. And yeah, how did it go? I see some thumbs up. That's a good sign. That's a good sign. No, okay, that's also a good sign. I think I thought I saw an error message. Okay, so without further ado, I invite on stage the judges that will present the solution to the problems that you have at least tried to solve today.
Hi, everyone. We hope you like the problems. I am the chief judge for this competition, and now me and all the other judges will present the solutions. So before starting, I'll show you some statistics about the contest itself. Let's see. Possibly. Okay, this is the list of the judges. I am Federico Glaudo, Andrea Ciprietti helped me a lot, and then there's the list of all judges. All of us are present, but Alex, I will present problems prepared by Alex. Okay, today I feel like you submitted quite something, and maybe the interesting statistic is that exactly half of your submissions were accepted. So like, I mean, I was expecting something worse, I was expecting more worse wrong answer or time limit, but you did very well, so congratulations. And 1,000 submission is already, it's enough, not only enough, it's much more than what we were expecting, so congratulations. In general, I would say that you went above my expectations. Like the general result, you performed very well, and I'm pretty proud of the general result of SWERC. I feel like the teams are improving a lot, and not only in number, but also in quality. That's very satisfying for who is organizing the contest. Okay. All of what you're seeing is just statistics for after the 4th hour. It's not after the 5th hour, so don't try to understand the final scoreboard from these statistics, because you just cannot. Okay, regarding languages, nothing truly unexpected. Like by far the most used language is C++, and there's some Python 3 and a bit of Java, and that more or less that's it. We are supporting also other languages, but you decided not to use them. Okay, so now we'll start directly with the problems. The first problem was solved by everyone. This problem was kind of authored by me, kind of authored by Andrea. It was meant to be a cakewalk problem, and I think I'll go very, very fast. Since all of you solved it, I'll just skip everything so that we can save some time. The problem was the problem about walking a dog, and just to give you some behind the scenes, this was the dog of Alex. Like the photo of this dog is actually the photo of a judge, the dog of a judge. Not the photo of a judge, of course. Thank you. And so that's it. And also the photo that was appearing in the statement itself, it's always the same dog. And as you may guess, the statement itself was inspired by a real-life event. So that's it. And I don't think it's necessary to show the solution since all of you solved it. So now it's time for Lifu to explain the solution to the second problem.
So I'm Li Fu, and I'm presenting the problem F, which is the second easiest problem ever. Let's see. Okay, so now this problem, we are entitled like 30 minutes to have all of the problems solved, so we are faster than you already, yeah. So let's first calculate the group. I eat PHP for breakfast, solving this problem in 11 minutes. Congratulations. And okay, let's go to the problem. So the problem is that you're given two lists, A and B, of members that are sorted decreasingly at 2 times 9 o'clock and 22 o'clock. So your task is to calculate how many members at least have been online between these two times. So the main idea of this problem is to calculate the complement of this problem, which is the maximum number of members that have never been online. So that's easy because we have a fact. I won't go to it in very detail. The fact is that members who haven't been online forms a suffix of B that is a subsuffix of A, which means that in A and B, these members, the order of these members does not change. So the final answer is the longest one among them. So we denote this answer as R, and for our original problem, the minimum number is the n minus r. So we can find everything here in overall complexity of O and n. So now let's introduce, let me introduce the Stephanie for the problem H.
So the next problem is controllers. As you can see, it's been solved by 86 teams. And it was first solved by ENS Ulm 1 after 14 minutes. That's very quick. To recap, the problem was you're given a string S that consists of several characters, which either are pluses or minuses. And you have a pair of integers, A and B. And you should insert either A or B after every sign, and then take the sum such that it evaluates to 0. And the question is this possible for the given integers or not? And the first step that you have to take to solve this problem is to realize that what it's actually asking is to determine whether there is an integer k between these bounds. Anyway, to determine whether there exists an integer k such that the formula that you can see over there is satisfied or not. And there are two cases. If A and B are equal, this only works if P is equal to M. Otherwise, it doesn't work. And if A and B are not equal, then you can rearrange this equation to get the following formula. And you can then easily see that this integer k needs to be an integer. So P minus M times P needs to be divisible by A minus B. And also we said that k has some bounds it needs to be between. So it needs to be between minus M and P, this fraction. And if those two terms are satisfied, then we can put the integers in a way that we reach the 0 sums. So yeah, that was the problem.
So, hi again. This problem was authored and prepared by Alex. This was maybe already not such an easy problem. Like, this was not meant to be super easy. And in fact, like, also the other problems were not meant to be super easy. But this is, in some sense, in my opinion, there's kind of a jump in the difficulty. So this was a constructive problem, which means that you had a lot of free choices. And in fact, part of the solution is to understand that it's better to restrict yourself as much as possible. This was solved pretty quickly after 25 minutes. So, to be concise, what's the problem about? In the problem, you are given a connected graph. We are talking about trains, but we are really talking about a graph. and you have to choose to assign a color to each edge. And what are the constraints? You have to make it so that a single color, like edges only in red or with any color, are not enough to connect the whole graph. But as soon as you choose two different colors, then that's enough. Maybe now I'll show you the solution. The solution is very short, but what's an important idea? An important idea is to notice that even though we allow you to use as many colors as possible, it's not really necessary. Right? There's no really reason to use more than 2 or 3 colors. Of course, 1 color is not enough, and we will see that 2 colors is enough almost always, and there's a special case when you need 3 colors. So let's start with the special case. The point is that when the graph, there are many constructions, I believe, but I'll present only one, and in this one you have to split in 2 cases. If the graph is complete, you're gonna do one thing. If the graph is not complete, when I say complete, I mean that all edges are present. And when the graph is not complete, you're gonna do a different thing. So when the graph is complete, this is what you're gonna do. So you choose a certain vertex, which is the special vertex here is vertex 1, and you color all of its edges but 1 in red, the remaining 1 in blue, and all other edges in black. What's the idea of this construction? With this construction, it's pretty clear that a single color can never connect everything, because, black is not even touching 1, so it's not connecting 1 to everything else. Red is not connecting 1 and 2, and blue is not connecting almost anything, so that's not working. But if you check, as soon as you take black and another color, then you get everything, because black is connecting almost everything. And once you get both red and blue, you are getting everything. So this just works, and it's pretty easy to come up with this once you decide to handle the complete graph as a special case. Okay, and what about a non-complete graph? The point is that for non-complete graph, you can even do it with just 2 colors. And this is the construction. So once again, you choose a special vertex, which is V, and what's the property of this special vertex? The only property you need is that V is not connected to all other vertices. And since the graph is not complete, you can find this vertex V. Once you have this vertex V with you, you just color its edges in 1 color, here red, and everything else in black. And if you check, since V was not connected to anything, to everything, red edges are not enough to connect all the graph. And for sure, black edges are not enough either, because they do not touch vertex V. While if you use both, of course, they are connecting, because this was one of the assumptions. And this is the end of the solution. There are many other solutions, but this is the only one we are presenting. Thank you very much. And now, there's Piotr, who's presenting uniform chemistry.
Okay, hi everyone. I'm going to talk about problem B, uniform chemistry, which was solved by quite a few teams. So the problem was, it was formulated in terms of researches, but for the analysis, we'll just say we have n positions and m tokens, and each token moves to positions with bigger numbers until it reaches position n. And you want to know the probabilities that for each token that it reaches the final position first. In general, there are n to the power of m possible states, so you cannot really enumerate all them or iterate or over all them, so you need to have some idea to reduce the state space. And the key idea, of course, is that the tokens move independently. And what does it mean? It means that for every token, if we compute the probability that this particular token needs a particular number of moves to reach the final state, then you can just multiply those probabilities. You can multiply the probability that this token reaches a certain number of steps by the probability that all other tokens did not yet reach the final state. And this way, you get the answer to the problem if you know those probabilities somehow. And now we need to solve the problem for each token independently. And for that, we use the dynamic programming. So dynamic programming, the state will be what is the probability that we need a certain number of moves to reach finish while we are a certain distance away from finish, here denoted by I. And then, the probabilities we need are just can be taken from this two-dimensional array. And in one jump, because we uniformly jump to any of the possible destinations, the probability can be expressed like this. It's just 1 over number of possible choices over the probability to reach the finish in one less move from all possible destination states. So this, you can just apply this formula, write 2 loops, and compute this values q, and then use them to compute the answer for the problem. So this dynamic programming has n squared states, and each of the states can be processed in linear time using this formula. And then the final formula to compute the answer for every token is n squared m. So overall running time is n cubed plus m squared, which is fast enough in this problem. So how did this problem come about? It was actually motivated by the snake and ladders games, the one when you roll a dice and you move forward, but sometimes you jump back or jump forward. Of course, one might ask, okay, there are so many problems similar to this one. Why did we choose this particular generalization or simplification of snake and ladders game? The reason is because it can be also solved for bigger constraints. So we can solve it when the number of positions is up to 10 to the power of 18. And in fact, this problem was used in the online mirror. So if you want some challenge, you can try to solve this one and submit code forces. Thank you. And now Andrea will talk about problem C.
There we go. The next problem by number of solves is another wine tasting event. So first of all, was a reasonable number of accepted submissions, actually more than we thought. Congratulations to B+++, for solving it after only 26 minutes. And so this is the scored submission distribution, you can see it. Let's go to the problem itself. So after stripping the problem of the background story, which by the way was the same setting of a problem from last year's work, after doing that, the problem basically boils down to you are given a string of length 2n-1 made up of W's and R's, so only these two characters, and you have to find any number x, between 0 and 2n-1, such that there exist n substrings of, you can read the length at least n, each of which contains exactly like x w's, so the same number of w's, which is x. Okay, so it's always good to provide some background and some intuition behind the solution, but the harsh reality is that there's not much time. So what I will be doing instead is just telling you the solution, which is a one-liner, and then providing a kind of a proof, somewhat formal proof of why it works. So the solution is this. Like you choose x, you consider all the substrings of length exactly n, you compute for each of them the number of w's, and you take the maximum of these values. This works, and it's very easy to implement in linear time. So why does this work? So you see a very simple picture here. So the long interval is the whole string. The red interval is any interval which has exactly x w's, where x is defined as that. What is the idea is that we want to modify this red interval so as to produce another one which is valid and has also x w's. So how do we do that? Well, let's say we want to extend it one position to the right. So we do that, and there are two cases, right? So the first case is if we have added an r. So what happens in this case is that the interval, of course, has the same number of w's as before, and the length is strictly greater than n. So we're all good, have to do nothing else. And the second case, more difficult, and it's where we have a w. So in this case, we actually want to remove some another w, and we do that by shortening the interval from the left. We shorten, shorten, shorten until we reach another w, and after that we stop. So now we have still x w's in the interval, but the problem is that it might have become too short. But if this were the case, now we are proving that this is a contradiction. If this were the case, then we could take a blue interval, which contains the red short interval, and has length exactly n, okay? We are extending it a little bit to the left. And this interval contains at least x plus 1 w's, because the red one contains x w's, and then we are adding at least 1, and it has length n, which is a contradiction, because x was the maximum number of w's. And so we have found another one, just another one. But now we keep doing this, so we keep extending the interval to the right until we get to the endpoint. Then we do the same thing, but on the left. And well, if you do some math, now I'll go very fast here. If you do some math, introducing like these variables LR for the original interval, we can see that in total we find n intervals, like the original one plus n minus 1, which proves that the solution that we presented at the beginning works. And this is it. So I'll leave it to Joanne.
Hello, so let's talk about problem L, which was a medium problem, I would say. So it asked to find the minimum number of bricks that you need to support n purple bricks at these positions. So as in the picture, as in here. So we just put it here. So one. So one interesting fact about this problem is that we were thinking about buying a few thousand Lego bricks and distribute them to the contestants, but it turned out that we had better ways to use the money, so we didn't do it. But anyway, let's go to the solution. So the first observation is that each purple brick needs to be supported by a chain of bricks that goes down to the ground. And these chains can merge. In fact, you should merge them as much as possible to save bricks. And so the overall structure will look like one or more trees, essentially. So to solve this problem, let's call f of LR the minimal number of bricks that you need to support an interval of consecutive purple bricks from L to R. And the key idea is to compute this number for all intervals using dynamic programming. Let's see how. And let's see it in a specific example. So in this example, suppose that the chains that support the first two bricks merge last, or do not merge at all. Then the best thing we can do is to build an optimal structure to support 1 and an optimal structure for 2, 3, 4, and then modify this overall structure by pushing the two things and making them meet as high as possible so that they merge as high as possible at some height that we call H14. And then we can count the number of bricks that we use, that is F11 plus F24 minus H14, which is the number of common bricks that we share between the two structures. Okay, and we repeat this with all possible sort of places where we can do the split. So if chains 2 and 3 merge last or do not merge at all, then we build two structures, we merge them, and we count the bricks. Turns out we just use 12 instead of 14 in this case. And the final case is, well, it's very, very similar to the first one, I guess. So again, you build two structures, you merge them if possible, and then you count the bricks. So in general, the best height HLR, you can easily compute it explicitly in terms of the positions of the two extremal bricks in the interval. Just pay attention that if those two bricks are too far apart, then it's not going to be possible to merge the two structures, so the height will be 0. Okay, this is the reason for the max 0, comma, whatever. Okay, so we are ready to put everything together. For a general interval, using this idea, we have a recursive formula in terms of smaller intervals. And of course, if you have an interval with just a single brick, the number of bricks that you need is just the height, h. As I said, we compute this number for all intervals, starting from the small intervals up to the large ones. And there is a quadratic number of intervals, and each f of LR requires linear time to compute, so this is a cubic solution. Okay. Let's leave the ground to Pedro. Thanks.
All right, so Italian data centers was a problem about graphs. Let me skip to the problem statement. And in this problem, we're given a colored graph that we're going to double exactly k times. And the goal is to calculate the diameter of the resulting graph. And since we're doubling it exactly k times, this is a huge exponentially sized graph. And so we have to find out a clever way of computing the diameter of this graph. So before jumping to the solution, let's just revisit very quickly how the doubling operation works. So we start with a graph, and for each vertex in that graph, you create two copies of that vertex, and you connect them using an edge. And you set them to the same color as the original vertex. And then for each edge of the original graph, when you double the vertices, if the edge is connecting two vertices of the same color, you connect the exact same copy. So you connect the first copy to the first copy, and the second copy to the second copy with edges in the new graph. If they have different colors, then you swap them. So you connect the first copy to the second copy, and the second copy to the first copy, just like in the picture. Okay, so let's try to analyze this a little bit to make some observations in order to get a solution. So let's say that GI is the graph after we double it I times. The first observation we should make is that we can describe the vertex in this graph GI by a vertex in the original graph G and a length I bit string. So for example, in this picture below, we can see that for example, the vertex on the right is the first copy of the second copy of the first copy of the vertex U on the original graph. So we can represent this as U, and then 0, 1, 0 that represents the bit string that represents which copy we're referring to. So each vertex of the final graph is just a vertex from the original graph and then bit string. The second observation is that the edges in GI between copies of a single vertex form a graph known as the hypercube graph, which is a graph where each vertex is defined as a bit string, and two vertices are connected if they're exactly one apart in terms of having distance. So if you can flip one bit and get the other bit string. So it looks something like this. And finally, the third observation you have to make before you can jump to a solution is that for given a edge in the original graph, UV, if you consider a vertex UB, so a vertex in now the doubled graph, which is represented by a vertex U in the original graph and then a bit string B, then if V and U have the same color, then UB is going to be connected to VB. So the vertex that U and B is connected to is the corresponding vertex V with the exact same bit string because the copies of the vertices are all the same. But if they have different colors, then it's the inverse of the bit string. So UB is going to be connected to VB bar, where B bar is the inverse of the bit string, which means we turn all ones into zeros and zeros into ones. And this is because we always connect to the opposite copy of the vertex when we're copying the vertex. So now to describe a solution, we'll just one quick definition it will make. Let's say that P is a path in our graph G, so just any sequence of vertices on the original graph. We'll call it an even or an odd path if the number of multicolored edges, so the number of times we go from an edge of one color into an edge of a different color, is even or odd. So like every time we switch colors, we count the parity of the number of switches. And the final observation is that the shortest path between any two vertices of the final graph is either the shortest even path between U and V plus the Hamming distance between BU and BV, which corresponds to finding the shortest even path in the original graph, and then taking basically the hypercube graph by changing every bit until we get to the vertex we're looking for. And the other option is the shortest odd path between U and V, and the Hamming distance between BU and the inverse of BV. So if we do an even number of steps, then we end up at the same bit string. If we do an odd number of steps, we end up at the inverse bit string. And so now the algorithm is just for every vertex of the original graph, you compute both the length of the shortest even path and the shortest odd path. And you can do this with the BFS, where you count parity. And then you compute the maximum for every pair of vertices UV. You compute the maximum between the even distance plus x or the odd distance plus k minus x, which corresponds to either going from taking an even path and then going from the vertex where you end up as to the 0 vertex, or taking an odd path and you end up at the inverse vertex, and then you have to also take the shortest path in the hypercube graph, which would be k minus x. And if you compute this, this is O of n times m plus n squared times k, which is enough. You can improve this a little bit, but that was necessary for this problem. And that's the whole solution.
Hi. So I'm going to speak about the spinach pizza problem, which was kind of a troll problem in the sense that we were expecting actually many more solutions, and the first accepted a lot before, but apparently people got confused and thought it was something much harder than it actually is. I mean, literally, the simplest thing you could come up with works, but I'm going to get to that in a minute. So the statement is the following. There is a pizza with the shape of a convex polygon and 2 players, Alberto and Beatrice, who are eating it by turns. In each turn, a person chooses what I call an ear of the polygon, which is a triangle determined by a vertex and the 2 neighboring edges. And they eat it. The thing is that they don't like spinach, so they want to eat the least possible amount of pizza that they can. In particular, they want to eat at most half of the pizza. So who can manage to do that in the end? So as I was saying, actually the easiest thing that you can think of works. So it's a greedy strategy, and at each turn, each player chooses the slice with the smallest area. Why does this actually work? So the main idea is that among all the triangles determined by 3 vertices in the polygon, there is one ear, so one triangle that you can actually eat because it's determined by 2 edges on the boundary, that has the smallest area. If you assume this fact that I will talk about later, then each player is eating at most what the next player eats. So you choose a slice, which is the ear with the smallest area, and the next player, whatever they choose, it is a triangle determined by 3 vertices in the polygon from before. Therefore, it has at least as much area as the slice that you just ate. And this implies that if n is even, then the first player eats something, the second player eats something more, then the first player eats something again, and the second player eats more again. So for each couple of steps, the first player is eating less than the second player. On the other hand, if n is odd, the first player is eating something, and then the same is happening. So the second player is going to eat less than the first player, even without counting the first slice. So if you add also the first slice, it's worse for the first player. So why is it true that among all the triangles determined by 3 vertices in the polygon, the smallest area is attained by a triangle which has 2 edges on the boundary? So the proof is basically on this diagram. So let's consider an arbitrary triangle PQR in the polygon. And what I'm claiming is that if I change a vertex, for example, R, that is not, so if a general triangle that is not an ear has a vertex such that at least one of the 2 edges is not an edge of the polygon. Therefore, if I look at the 2 neighboring edges, at the 2 neighboring vertices to the base PQ, which I call A and B, either A or B has smaller area than the original triangle. Why is this true? Because otherwise, R would be lying below the segment AB, and it would contradict the convexity of the polygon. So if you believe this observation, then by eating at each time the smallest possible slice, you're going to win. Something very short about the implementation, you can implement this in quadratic time by checking at each step all the possible vertices that you can pick, and this actually works. But there's actually like an n log n solution using a priority queue or something like that, and we decided to put a smaller n, like 100, in order to, well, make it a bit more interesting.
Hey again. So library game was like almost the same problem. Like it's another interactive game. There are a lot of interactive games in this work. It had only 2 accepted submissions before freeze, but yeah. The first one after 3 hours and 2 minutes by UPC1. So statement is a bit complicated to explain. So basically, there's a game between two players, A and B. Initially, they are given n numbers, x1, x2, xn, and an integer m that defines this interval 1m. So they play in turns. In her turn, A chooses one of the initial n integers. She erases it, and let's call this integer y. Then she also chooses an interval of length exactly y, which is a subinterval of 1m. Okay, then she says this interval to B, and B has to choose an integer b, which belongs to that interval. So they play like this for n turns, and after that, B wins if he has selected the same number at least twice. Otherwise, A wins, like if B has chosen n distant numbers. So yet again, you have to choose who you want to be, play, and win. Okay, so if you play a bit with small cases, even n equals 2 helped a lot here. You could think of and conjecture that for A, it is always convenient to play, let's say, decreasingly. Like decreasingly means she first chooses the largest xi, then the second largest, and so on and so forth. So let's say this is true. We seek a strategy, winning strategy for A, assuming that she plays like this. So from now on, we will assume that the numbers are sorted decreasingly, x1 greater than or equal to x2, and so on. What can we think of? So when, let's say we are at turn I, generic turn I, B has chosen I minus 1 number so far, and when can A not lose at this turn? Well, when there is a gap, like these I minus 1 numbers define I gaps, and if at least one of these gaps has size greater than or equal to xi, then A can place an interval there. So let's come up with this very dumb strategy, like very naive. Just A places, if there is such a gap, A places an interval there. It doesn't matter which gap, if there is more than one. It doesn't matter where she places the interval, like at the beginning, at the end, in the middle, doesn't matter. She just does this randomly. So when does this gap exist? So if we don't have any other information, one sufficient condition for the gap to exist is that xi is less than or equal to the integer part of m over I. Why is this true? Basically because of the pigeonhole principle. So if you have I gaps that add up to m, at least one of them will be at least m over I long. Then you have to do the maths a bit like more carefully, but it turns out that this is a sufficient condition. And we can actually rewrite this a little bit more simply as I times xi less than or equal to m. So this is more symmetric and doesn't have the floor. Okay, so we have proven that this strategy works if this condition is satisfied for all i's from 1 to n. So now our claim is that if on the other hand there is one integer k from between 1 and m that does not satisfy the condition, then B has a winning strategy, and we are going to prove that. So suppose that there exists this k, such that k times xk is strictly greater than m. What does B do? He only focuses on some numbers which are special for him, and these numbers are exactly the multiples of xk to xk and so on, the ones that you see here. So what's the rationale behind this? These numbers are, well, first of all, they are floor of m over xk, and they form some gaps. Each gap has size xk minus 1. So what happens now? That whenever A chooses a number, y, which is greater than or equal to xk, which means, recall that we are assuming the numbers are sorted. So whenever A chooses I less than or equal to k, then the interval, whatever interval she chooses, the interval will cover at least one special number. And so B will select that number. And then we are done, because this happens, as we have seen, as we have said, m over xk rounded down times. And sorry, this happens k times. Since k is greater than m or xk rounded down, again, by the Pigeon principle, there is at least one special numbers which will be chosen twice or more, so B wins. And the implementation is simple with the given constraints. You can just do a linear scan of the whole interval at each turn. So the complexity is O of n times m, and this fits. Okay, leave it to Simon.
Hi. So the next problem was about a controversial dish in Italian cuisine. So it was first solved half an hour before the freeze by Heroes of the Sea. And so there is an interesting 7% acceptance rate. We'll see why. So the problem was yet another game, but we can rephrase it as a game on a tree. So we had a tree, and Alessandro and Bianca were playing and alternately extracting leaves from the tree. And if we denote M, the maximum index of a node selected by Alessandro, Alessandro wanted to maximize M and Bianca wanted to minimize M. And so the question was, if both play optimally, what happens? So as for many tree problem, we can try to solve it on a chain first. And we can make a few easy observations. So first, if a node is initially a leaf, of course, Alessandro can select it. A second observation is that if n, the number of nodes, is even, Alessandro can actually always select node number n. And the way to see that is if he never selects anything which allows Bianca to select n, it's going to be Bianca's turn when one of these leaves will have to be selected. So now if n is odd, which is the only remaining case we have to solve, we can also notice that by also counting and the parity of n, we can select any node which is an odd distance of node n. And the reason why, it's because when this pattern occurs, it's Bianca's turn and she has to uncover node number x. So we solved the problem for chains, and we can try now to generalize it for trees. And what we said actually works. So for example, Alessandro can still select any initial leaf, and if n is even, Alessandro can still select node n. And if n is odd, it's still possible to select any node at an odd distance of n. But the reason for many failed solutions was that it's not enough. So there is an extra case. So to discover this, we have to go through a lot of test case, like example by hand. And so we can see that here, in this first case, we have 3 nodes, x, y, and z, that we took at an even distance of n, because we don't want this to be already covered by previous cases. And when this pattern occurs, it's actually Bianca's turn to play. So she has to uncover either x, y, or z, and then Alessandro will be able to take this node. But in the second case, which almost looked like the same as the case number 1, notice that if n is odd, it's actually Alessandro's turn to play. So we have to be careful here with this type of structure. So we will define a node T to be called the median. So the median is the node which lies in between 3 nodes which are not in the same chain. And we have an extra rule which says that, okay, if n is odd, Alessandro can always select the minimum between x, y, and z, where there is a median node between x, y, and z. And x, y, and z are at even distance of not T. So that's case 1, but not case 2. And so going through all these triples might take a lot of time, but we can assume that n, the node n, is going to be either x, y, or z, or the median T. So all of these rules that we described can be computed with a DFS, and it can be proved that this is the optimal solution. That's it, and next problem will be presented by Cesc.
Okay, so this is the last problem and was not solved by any team before the freeze. Let's see how it was after the freeze. And yeah, the problem is that given M railways and N trains, such that each train will cross a straight line perpendicular to the railways, we need to find how many speed change we need to go from one side to the other in a straight line without hitting any train. And we had a maximum speed and a maximum time to do that. So the first thing that we have to do is to look at this problem as a geometry problem, where each train is represented as a straight line in a plane where x coordinate is distance from the validating machine, and the y coordinate is the time that we have spent since we started. So each train is a vertical segment. Yeah, trains are vertical segments, and our moving in a constant speed, it's also represented as a straight segment, not vertical, but in this case, we see that there's a solution. So a solution has to, it has two conditions. The first one is that it's a concatenation of straight segments connecting the x equals to 0 to x equals to n plus 1. That means that we go from the first validating machine to the second one. And also that all the segments that we choose has a valid slope, so it represents a valid speed, and they don't hit any train. So we cannot cross a train segment. And yeah, every time that we change the slope is a change of speed. Now, we can show that we don't need to focus in all the possible segments. We can focus in a finite set of these segments. And this finite set is formed by all the segments that connect two train endpoints. It's the one that we can see in the pictures. And also that connects the first starting point, the 0, 0, with any train endpoint, and the last valid point, that is to arrive at the last second, at the second validating machine, and connect it to any endpoint of a train. The second set of segments that we have to consider is the one with minimum slope, that this means maximum speed, that touch any endpoint of a train, or the starting point, or the endpoint. So if there's a solution to this problem, it can be found using only these segments. And also an optimal solution can also be found using only these segments. With all that, now we only have to focus of how many intersections we need to cross before we go from x0 to x0 to xm plus 1. So one other thing that can be shown is that the change of speed will be either in a railway, that this can be computed easily because there's not many intersections in the railways, or between two railways. And that there will be at most one change of speed between two railways. So we only have to focus in an intersection point between two railways. So to do that, we will check every time, increasingly from left to right, to the intersections between two consecutive railways. And each time, we will keep for each segment, for each speed segment, the number of intersections that we have to cross to go from x equal to 0 to this segment at this point. It can decrease if we keep computing. To do that, we will use a Fenwick tree of minimum values and start computing the intersections from in increasing order of the intersection of the speed segment with the first railway. That is, we start with this one and we increase like that. And then we have to do the same in the opposite direction, in the increasing value of the intersection, but with the other railway. Yeah. So this way, we compute all the possible change of distance between the x equal to 0 to that segment. With that, we have the solution. So if there's a solution, we already computed that. And the first thing we have to do is to compute all the segments. This can be done in m times n squared times log n, because we need to check that the segments that we are creating that are n squared don't intersect with the train segments, that this can be done easily with a binary search to check that we're not intersecting any train. Yeah, the next thing is to check for intersections between two railways. This can be done with the Fenwick tree in n squared log n. And as we need to do that m times, because there's m railways, the total complexity is m times n squared times log n. And I think that's the last slide. So thank you for listening to our presentation.
Okay, I'm back. Hi. I knew it. I knew that it doesn't work. Is it on? Is it on? It is on, but it doesn't seem to work. Also because there's no USB. The other part is not attached to the computer, so I'll do it from here. Okay. Oh, never mind. Never mind. Okay. So what was I saying? So we are at the closing ceremony. I haven't touched anything. We'll see how it goes. So it is now time to do a bit of thank yous to all the people that helped making this work. And yeah, there is a delay of like 1 second when I click it. And let's see who to thank. First of all, Huawei, our sponsor inherited from ICPC. Also, JetBrains. As last year, I want to do a quick poll. How many of you used, let's start with Sea Lion during the contest? Not that much. Sorry, JetBrains. Let's see how many used PyCharm. And how many of you used IntelliJ IDEA? 1, 2, 3 people. Okay. I mean, they're nice, their ideas. Maybe all of you still use VI or something like that. Well, so I want also to thank our local co-sponsor, Bending Spoons. Thank you for your reiterated support, and also thank you to James Street. Okay. Oh, and let's not forget our bronze sponsors, Google, Sheffield, and OT Consulting. Okay. So I want to thank also a lot of people. Let's start with the people from, let's say, the SWERC family, the ICPC family. I want to thank Bosena Mannova, Fernando Silva, Antoana Marilli, and Veronica Soboleva. I want to thank myself, apparently, and also the other two main roles, our Chief Judge, Federico Glaudo, and our Chief Technical Officer, Edoardo Morassuto. Thank you. I want to thank, again, myself, the organizing team, which are also Emanuele Esposito, Samuele Turci, Filippo Soldati, and Alisa Lupidi. I want to thank the technical staff, Alessandro Fulgini, Bjarke August Gudmusson, Edoardo Morassuto, again, Jap Eldering, Luca Versari, Mart Plugimakers, Michael Vasseur, Nicky Gerritsen, and Tobias Werf. I want to thank our wonderful judges, Andrea Ciprietti, Alex Daniluk, Cesc Folk Aldehuelo, Federico Glaudo, Li Fugin, Simon Mauras, Petr Mitricev, Gerardo Ros Jimenez, Giovanni Paolini, Pedro Miguel Reis Bento Paredes, and Stephanie Zwinden. I also want to thank our media and artistic staff. We have Marco Patriarca, Alessandra Sendi D'Amico, Tommaso Tommy Calvani, Francesca Meco Lauria, Francesca Sherin Solitro, Michele Moliurni, and our graphic person, Robin Usai, who also did this. And just a moment before going to the volunteers, because I forgot to make the slide, I also would like to thank Elisa Madaro and Aika, which lended us their camera for the opening ceremony. And last but not least, and I'm hopeful that this is the last one, I want to thank the volunteers, which are Lorenzo Ferrari, Noemi Gambirasio, Samuele Artico, Mirko Faina, Rick Wouters, Davide Paolillo, James Bamber, Cecilia Morigi, Adriana Carollo, Francesco Cola, and Maylin Martosiardo. And of course, thank to you, all the contestants, for coming here, and also thanks to all the coaches who accompany you here. Thank you. I made this as quick as possible so that now we can go to the fun part. The resolving will be done by Andrea Cipretti and Federico Glaudo. So I welcome to the stage Andrea Cipretti to start the resolving.
Yeah, I'll say a couple words before starting. So I've never done this, and we're running out of time. There's a lot of pressure. Last year, Federico did an amazing job. I'm going to be awful, terrible, so please forgive me.
Okay, so this is the moment you have all been waiting for, maybe. And let's reveal the scoreboard, the final scoreboard. So some of you will be familiar with this interface, and some of you won't. So I'll briefly explain how it goes. You can see a tentative scoreboard here. So this is the top of the scoreboard, but we start from the bottom. And there are various colors. Green, normal green, so each column is a problem. The normal green boxes, slots, are problems that have been solved before the freeze. The dark green ones are problems that have been solved before the freeze, and also it's that submission was the first solve for that problem. Red slots are problems that have been attempted, not solved before the freeze, and not attempted after the freeze. And finally, yellow slots are problems that have been attempted after the freeze and not solved before. Hope this is clear. And also you can see some numbers, which are like the number of submissions and the time in minutes of the last submission. Okay, so I'll now press a key, and this will go all the way to the bottom. Yeah. I can't speed it up. How many teams are there? Yeah, 120, as the quiz from yesterday said. Okay, so we're going to start from the bottom, and yeah, we will start with reveal. So what happens now? Well, you will see what happens. So let's see, how do I do this? We have the QNF1 team, which have one submission. Okay, this submission is not accepted. We move on to, an accepted submission from PBI. Let's go on. Another accepted submission from, we have get name, UPF, wrong submission MB, and another wrong submission, I'm sorry. Okay, attempted submission, and it's good for QNF A, CPU, University of Aquila, and not wrong attempt, I'm sorry. Nothing for GIS, Jean-Pierre 2, wrong attempt. Sorbonne Blanc, nothing. ECL3, 2 attempts, and 1 is correct, congratulations. J.U. Belleux, whatever, nothing. Serge, no, wrong attempt. And another wrong attempt. Polydata, 2 attempts, 1 wrong, 1 and H, still wrong. Nothing for PBI, nothing for UBLDE, whatever. CUNF A, this is the last thing. ECL3, wrong attempt. ET Simp 2, and yeah, successful attempt. And it moves on. Error 2 F4U, another correct attempt. Pending submission, and not good for Hakbullah. ECL2, same. ET Simp 1, correct submission. Genova 2 from Genova, and not good for B, and yay, it moves on, it moves up. UB, LK, UBIK, nothing. Overflow, UDP, nothing. Sapienza White, University of Sapienza Rome, incorrect, correct, moves on. Programmers, no, nothing, I'm sorry. Boys, TD Couts, nothing. Drop table, cool reference, but nothing. US synchronous, wrong submission, greedy to SAEs. And, well, first of the 3, it's okay. 6F squad, yay, second submission is good. Gli informatici, nothing. And 1 submission here. Yeah, coffee in hexadecimal moves up. UPV, EU2, incorrect, and another incorrect. Sapienza Red, yeah. So that's what you want to see at SWERC. That's the whole culture. Congratulations. But this is, yes, I knew it. ET Simp 2, nothing. Error 2, L4U, nothing. Quick bits, nothing. Again, 6F squad, second submission, and it's wrong. Third one, 4 minutes, no, it's wrong. Nothing for ET Simp 1. Genova 2, nothing. C minus minus, nothing. Coffee hexadecimal plus plus, nothing. 1 submission for Sorbonne, who's not, no, it's not good. Telecode of duty, nothing. Sapienza White, nothing. FDS, nothing, very boring. Greedy to whatever, yep, moves up. The Morgan, nothing. Bogo solving, yay. First of 3 pending is good. Turing Net 7, nothing. Presentation, yep, good. And, well, 1 minute after the end, rises, whatever. Sapienza Red, that's one. We were all hoping. The Fan team moves up. Polychotomy, nothing. 1 minute from the end. Jean Perrin, I think. Last Datale Red, yep. Last submission, it's a good one. INSA 3, wrong submission. Saint-Germain-des-Prés, 1, yep. INSA 1, 2 pending submissions, 1 wrong, and the other one on K, wrong. Telecoders, B, good one. UPV, whatever, nothing. AFL Polimi, 1 correct submission. Venta de Pantalones, wrong submission, and stays there. Peak to S, yep, moves up. Again, presentation, whatever, yes. As it goes up and up and up. Greedy to, yeah, still good. Very interesting scoreboard. ECL1, wrong submission, and correct one. Bogus solving from Padua, no and no. 75th position. Saint-Germain-des-Prés, nothing. The Fan team, nothing. Fantastico debug, nothing. Tinengo's here, Polimi, wrong. Last Atali Red, nothing. Don't you see nothing? I don't see nothing. Yep. Masters of Breaks, correct submission and B. Fallback solutions, Turing, nothing. Telecoders, problem C, nothing. And problem K, correct. Codeforce 1, all done. ENS space, problem B, 1 minute before the end, nothing. AFL Polimi, nothing. EPFL 2, 1 on C, 1 minute, nothing, and 1 on K. Yep. Okay, nothing for team 2, the Verano. Peak 2S, nothing. Rated C++, Porto, nothing. Java Man, yep. Problem C, congratulations. Fusilli again on C, and this is wrong, fortunately. Coffee limit exceeded, yep. Good one on B. ENS slip, another good one on B. Then we have 2 for Uniboys, 1 on B, and it's wrong, and the other one, I can guess, yeah, it's wrong. Uniboys, Unibo, nothing. Trento University, Fenwick, Trento, nope. ECL 1, nothing. Presentation, error, nothing. Ready to say is nothing. Okay, 1, nope. Another one for Trento. Yes. On the very last problem, EPFL2, nothing. Masters of Breaks, 1 on C, but no. Telecoders TP, no. It's gonna code it to ya, no. Javaman, nothing. And no. And another one, no. Last Atali Green, yes, yes. Milan. Then we have another from Trento, but nothing. Caramba, Polimi, nothing. And this one might be, yep. Again, Coffee Limit exceeded. They stop here. Ian, Sheep, nothing. Very last minute. Sig Kill. Again, whoa, this was very unexpected. I know this is a very good feeling. Ian slip, nothing. Ian ICPC, wrong submission. Toroidal, polyhedrons, wrong submission in C. Another on C, slipping Jimmy's, wrong. And this is E, late submission. It's still wrong, late but wrong. Genova stops here. Television there, wrong at the very last minute. Walk like the Egyptians, yep. Good submission. UPC2, wrong on C. Another C, overkill, polytoast, wrong after the 13th submission. Amazing. Sorbonne Bleu, wrong. Then we have, well, okay. Starting good, a lot of hope. UPC3, 1 wrong and 1 correct. Nice. Save Water, ETH, wrong, last minute. Trento, so yeah. Last Atali Green, nothing. Sickle, nothing. A bunch of nothings here. Caramba, Polimi. And 1 submission, 11 minutes. Yep. Nice. Top of the mountain, wrong, and it stops here. Sorry, flag 11 from University of Pisa. Yes, with problem E goes up. In extremis, 1 wrong and the other 1 wrong, both at 1 minute from the end. Walk like the Egyptian stops here. UPC3 stops here. INSA 2, we continue this streak. 1, 2, 3 wrong, 4 wrong, 5 wrong, and please give it, nope, give wrong. Round of applause for trying. Sapienza Black, wrong and correct, nice. SNS, Corona Fighter from Pisa, 1 wrong and 1 right, 2 minutes from the end. Here we have, yet another, whatever this is. So wrong. I guess still wrong. This might be right, and it is. Yep, congratulations. Bologna University, no, it stops here. La Statale Blu, Milan. 1 no, 1 yes, problem E. And ICPC, nothing, and 3, nothing. Flag 11 again, no, last submission, and it stops here. Sapienza Black, University of Rome, nope. Corona Fighters, yes, another good one. 2, last submission, wrong. And Suma, whatever, wrong. Last Atale Blue, 1 wrong. Yes, 1 right, 1 correct. Who's up? I'm not going to read this. This is just Padua. Okay, 1 wrong, 1 no, and please, yes. X cube, a simple one. Harbor Space. Is it Harbor Space? Yep, probably. 1 right. All right. Again, Corona Fighters, last submission, yes. Congratulations. Last Atale Blue, Nimi. It moves up. Those guys again, but they stop here, fortunately, for the name, just for that. SWERC Chaos, nothing. Xcube again, it stops here. I eat PHP for breakfast, yeah. EPFL1 goes up. Jokers, yes. The Outlaws, yes. Very nice, very nice. And Determinant from ETH, yes. Masagon Stau. Wow, this is amazing. Like, a lot of good submissions in a row, and Caravana Fighters just ruins everything. Last Totale Blue, Unimi, nothing. Oh, yeah, and that's the end of it. That's the end of it. I will now leave the stage to Federico, who will do the medals.
Okay, now, as you may remember, it's time for the medals. We are going to give 8 bronze medals, 4 silver medals, and 2 gold medals. But before that, I mean, we already know the first bronze medal, but we still have to understand quite something, because a lot happened during the freezing time, which was the last hour of the contest. But before that, if they are in the room, and I suppose they are, we'd like to call on stage. No, we'd like to call on stage the team by Jane Street. They participated unofficially to the contest, and they actually performed very, very well. It was not a one-member team. There were also other members. Are other members somewhere? Yes, they are. Please come up on stage so that we can also take a photo. Yes. So, on the side. A big round of applause. They're solving 11 problems, possibly enough to win the contest or not. They are one of the main sponsors of the contest, so a big round of applause to them for their performance and to their company. Thank you very much. Thank you very much. Okay. So they told me from the behind the scene that I have to be a bit slower because something is not ready. So what I can tell you is that I don't know the results of the contest. I have no idea who is winning. So I'm unfreezing it for you, but I'm unfreezing it also for me. I'm not sure I can start with the bronze medals, but this is a good thing, I guess. Okay. This is a good thing, I guess, because I wanted to add something which is kind of out of the schedule. So first of all, I'd like to call Eduardo, our CTO, on the stage. Big round of applause for Eduardo. Okay. Sorry, what? Keep it. Okay. I want to read you a brief speech. So, me and Eduardo, we have been the organizers of SWERC for the past 2 years. We are honestly quite proud of the 2 editions we have hosted, and we believe that they were a success. This is not, as you may guess, a two-person's effort. We could not have achieved any of this without our teams, or the sponsors, or the volunteers, the artists, the photographer, those who are now handling the cameras, the microphones, and everything. Those who are cleaning the room, the staff for the banquet, and many others that I'm surely forgetting. Each of you played a critical role in making this event a success. But when you go, and this is something that is true in general in life, I believe, when you go from the base to the peak in the pyramid of the organization of an event, and this is very true for SWERC, the amount of effort, responsibility, and time devoted grows exponentially. So you may see the color of my t-shirt and Eduardo's one, they are black, which may suggest that we are at the very peak of the organization. And if you look at the website, we are in fact among the 3 members at the very peak of the organization. So you may think that no one is doing for SWERC much more than us. Like we must be the ones devoting the most time. This assumption is false. In fact, Dario, the director of the last 2 editions of SWERC, did a massive job in our opinion. He did more than the 2 of us from any point of view. He went above and beyond in his contribution to SWERC, and he took a lot of responsibility. Was under a lot of stress, and he worked almost full-time for months at the organization of SWERC. This is almost trivial, but everything is for free. He's the most reliable person we know. He accepted this responsibility and overcame the many challenges that came his way. When we asked him to be the director 2 years ago, we would have never expected nor demanded this level of commitment. Our expectations were high, but he delivered just much more than anyone could reasonably expect. Moreover, me and Eduardo are in some sense trained for our roles. This is what we are doing since years. But for Dario, this was not the case. This was a first time. He had to push himself out of his comfort zone and rise to the occasion. We have a great deal of respect for his job, and I would ask him to come up on the stage, and please give him the biggest round of applause. This was just a thank you for Dario. Thank you very much. And that's not a problem. He's saying that he's gonna cry. For those who are not fluent in Italian. Thank you very much, Dario. A big round of applause.
Thank you. Thank you.
If there's anything you want to say, and if you're not, that's fine, okay.
Thank you.
Grazie mille. We love you. Okay, so Jane Street is done. Dario is done. We can go on with the medals. And we already know the very first medal, I think, so not much suspense here. The first ones are from University of Milan, La Statale Blu. For each and every medal, you'll have to come up on stage when I call you. You will receive prizes from Huawei, and in fact, all medalists will receive prizes also from JetBrains. But in order to get the prizes from JetBrains, you'll have to go to their desk outside after the end of the ceremony. Huawei is going to give you a prize on stage. JetBrains is going to give you a prize later. And when you are called on stage, please stay for a photo. So just one moment, because I have to find a list, and then we can go on. Okay. So please, La Statale Blu, a big round of applause for our first bronze medal. They solved 9 problems. One of the volunteers, Davide Paulillo in particular, is going to give them the medal. Not too fast, please. So in the meanwhile, I'll tell you that we were not expecting 9 problems to be necessary to get a bronze medal. So in general, I'm honest when I say that the level of SWERC is clearly rising. Thank you very much. Okay. So before I go on, I want to say that in some sense, 9 problems, like the remaining problems, the 3 remaining problems, we consider them to be, I mean, we believe there's quite a gap in the difficulty. And in our opinion, like solving 10 problems, it means that you have solved what we consider at least one hard problem. So from now on, let's find out who's the first with 10 problems. After La Statale Blu, we have a team from Tel Aviv, I believe, Jokers. They did very well last year. I don't know if it's the same team, of course. It's just the same university. And it seems like they're trying I. What I want to say before just revealing the result is that they're sending this 6 minutes before the end, which is usually not a good sign. And they have already 5 submissions, which is also not a good sign. And in our opinion, this problem is much harder than problem E. But they decided to go for it, and they went for it. And maybe I have to push one more. Is it? Will we find out? Yes! Congratulations. Okay, even worse, even worse. So here we have 9 submissions and 1 minute from the end. But I was not expecting also the previous one to be accepted, so who can tell? Problem G, this one, I mean, it was very easy to get a lot of wrong answers, so who knows? This is from Arbor Space. And the result is, they might become either between the first 3, and this is wrong, we're sorry. Please come up on stage, Arbor Space. The medal will be awarded by one of our artists, Francesca Solitro. Thank you. We'll wait for the prizes. Okay, next we have the first team from EPFL, which is a university in Lausanne, Switzerland. They have 1 attempt and only one at 298 minutes, which is 2 minutes before the end of the contest. Let's see. If they get it, they are surely getting more than a bronze, I believe, or not? No, maybe not. So let's not make any assumption, because there are many yellow things here. And do they? They're not getting it. Please, come on stage. Thank you very much. EPFL from Lausanne. They're getting the award from our CTO, Edoardo Morassuto. I was told that you want to have a microphone. You still want to have a microphone? Yes, you can. I guess you can. Actually, you can come here.
I just wanted to say thank you to all the organizers and everyone who contributed to this event. For us as participants, we just come here to have fun, and sometimes it's hard to appreciate the amount of work that goes into organizing these events. So I want to thank all of the organizers in the name of us, the participants. Thank you very much.
Thank you. Very well. So, still no one with 10 problems. But, I mean, UPC from Catalonia, which maybe it was said in one of the quizzes that they are the ones with the largest number of wins overall in SWERC. I'm not even sure. Maybe I'm wrong. Who cares? It's true. It's true. Yeah. One judge from UPC is saying that it's true, so it must be true. They have two different problems attempted during the last hour. One of them was attempted 1 minute before the end, so let's start from the other one. And it turns out that the other one, I mean, this must be correct. This was wrong. I'm sorry. I was sure. I was sure. But the other one, 8 attempts, 1 minute from the end. What a plot twist would it be? And that's wrong. Please, come up on stage, UPC. Congrats in any case. So, next one. A team from ETH, up to last year, was working in ETH. Will they manage to get problem I correctly? This looks very good for them, but who knows? So 2 attempts, they have solved also 1 problem after the last attempt on problem I. They might be, and this looks very likely, but I was wrong once, so who knows? It might be that they are the first one solving 10 problems. And they are. Congratulations. Very well. So it seems that we already have 4 teams with 10 problems. Now the mic is better. Yes. Is that one? Top. Okay, so let's go on. Istituto Tecnico di Lisboa, the Outlaws, which is not the same as University of Porto. So 2 very strong teams from Portugal this year. They have 1 submission at the very, very end of the contest. 1 minute before the end. I can imagine the mood of the team at that moment. Problem G. And are they solving 10 problems once again? They're not. Please welcome them on stage. Istituto Tecnico, the Outlaws. The medals are awarded by one in the staff of the organizers, Emanuele Esposito. E che cazzo. But I'm not turning it off. I'm not turning it off. It is awarded by Emanuele Esposito. So, we go back to Tel Aviv with a different team. This team name seems very similar to the team name from last year, but I'm not so sure, so I'll not try to remember. And they have 5 submissions on problem G, which, as I said, it's very easy to get it wrong. But the last submission is not so close to the end, and I think we are going to see a 10 accepted problems from them, but let's find out. So, Tel Aviv University, team name, 5 submissions, and it's correct. Congratulations. Ooh. Okay. As I said, up to last year I was working at ETH, but in fact, you might think that the competition is kind of biased, because I was also a student in this university, University of Pisa. They did very well this year. Let's find out if they did just very well or exceptionally. So, 6 submissions on problem G, and this doesn't look so good. 2 minutes till to the end. 6 submissions, and that's unfortunate. But they have one more chance to go up in the ranking, which might be necessary to get silver medals now. And 1 submission on problem I. Correct. Congratulations. It seems like to get a silver medal, you need 10 problems, and if I have to bet, but just my bet, it might be that to get a gold medal, you need 11, but I can say this because I have no idea about the answer, so I'm free to say whatever. So, then, 2 more. University of Porto, they are kind of the winner of the practice. When I say this, I mean that they were the first to solve the whole problem set. Let's find out if they did very well in the contest or, once again, exceptionally. 2 submissions. Problem E, which we consider somewhat easy compared to the other ones at this level. And we have 2 submissions, and it's correct. Congratulations. Possibly solving 11, but we'll find out later. Once again in Tel Aviv. I mean, how many teams from Tel Aviv are there? This is the third, or I'm meeting... This is the third one. Wow. Congratulations to Tel Aviv University that is able to provide 3 different teams at this level. So, 2 submissions. The first one, 2 submissions on problem G, I guess, and they are not solving it close to the end. They're solving it just after the freeze. Is it correct? No, it's not. That's fine. They have also 2 submissions on problem I. Doesn't look good, but who knows? And it's, I hope for them it's good, but who knows? It's correct. Congratulations. They are now in silver position, and I believe they cannot be, no one can remove the silver from them, because there are not enough teams below. So, and now we have École Normale Supérieure, which is kind of the French version, or they might say that we are the Italian version of where I studied in Pisa. They are usually performing very well at SWERC. Let's find out what they're doing. So, 2 submissions on problem G, and both of them are far from the end of the contest. And if they solve it, they're going very strong, I guess. Let's find out. Yes, congratulations. And they might have 11 problems, so they might be the winners, in fact. Okay, so we can now finally call on stage the first Tel Aviv University. Jokers, please come up on stage. A big round of applause. The medal is awarded by one of our sponsors, by a representative by one of our sponsors, Cristina Nizzoli for OT Consulting. Thank you very much. And guess what? Tel Aviv is going off the stage, and Tel Aviv is going up the stage. The other team from Tel Aviv, once again, 10 problems. Big round of applause for Tem Name. And they're also the first ones to solve problem A, which was not super difficult, but still they were super fast. Congratulations. Please come up on stage. They're awarded by a representative from another of our sponsors, Sheffield, and the representative is Cesare Colombo. Thank you very much. Okay, so once again, not much suspense, but this is the last of the bronze medals, and this goes to ETH Zurich. They solved once again 10 problems. So just solving 10 problems was not even sufficient to get into the silver medal spots. So a big round of applause for the team Determinant from ETH Zurich. This is the last bronze medal, and it will be awarded by a representative from one of our sponsors. The sponsor is Google, and the representative is just a random employee of Google, Piotr Mitryshev. Thank you. So now bronze medals are finished. We go immediately into silver medals, and once again there is no suspense here. The only suspense is who's going to award the silver medal. So let me check. And let's welcome on stage the team, another team from Tel Aviv University, I guess the last one today, yes. Bestagons, they solved 10 problems with rather fast. So a big round of applause for the first silver medal, Bestagons from Tel Aviv. The silver medal is awarded by one of our sponsors, Huawei, and the representative is Shar Belkar. look at the medals of the coach. Okay. So now there's some questions here. The main questions is, and I have no idea about the answer. I'll just make some comments before going on with the reveal of the scoreboard. It's pretty clear from the scoreboard that no one solved 12 problems. Problem D was very hard. We knew it very well. We put it there because we were not 100% sure that the remaining problems would be enough to keep all teams busy for the whole time. It turns out it did. In fact, maybe its presence in the problem set was what made the remaining problems sufficient to keep everyone busy. It's pretty clear, like before the start of the contest, it was pretty clear to us organizers that there was a team that was expected to perform very well. Just because it's pretty known in the, it's pretty known. There are ratings and you can just compute the strength of a team, and we did it, and there was one team which was performing very well. And it did in fact perform very well at the beginning of the contest. I'm talking about PPP from Arbor Space. They performed very well, and then they got very much stuck on problem D. Problem D was meant to be the hardest problem of the problem set. For some reason they considered it differently, and they tried it a lot. This is just to say that problem D was not solved, and this was kind of expected from our perspective. What was not expected was so much doubt at the very top of the ranking. I have no idea who is going to win the competition. I don't know if 11 problems will be needed or not, but I'm saying this now because the next team, they have one more submission after the 10th one, and this might, in fact, as far as I know, be sufficient to win the whole contest. I have no idea if someone is getting 11 accepted problems. So, let's find out. We have University of Porto, which did a wonderful performance, unexpected. We didn't know they were so strong, so congratulations to them. And let's find out, in any case, and let's find out if they are the first ones solving 11 problems. This would give them pretty confidently, in my opinion, a gold medal, but who knows? Let's find out. The problem is they submitted it very close to the end of the contest, which is not a good sign, but who knows? That was not. Please, University of Porto, you had a wonderful performance. Come up on stage. They're also the first solver of problem G, which was a good news for us judges, because we were having some doubts, because everyone was getting only wrong answers, like 1,000 of wrong answers, so we were not sure about the correctness, you know? Doubts. Thank you very much, University of Porto, and they're going to be awarded by Andrei Ivanov of JetBrains, one of our sponsors. Thank you very much. Okay. Next one. I feel like they had an amazing performance. I was discussing what they could do before the beginning of the contest, and I said that if they had a good day, they could get top 5, and they had a very good day. So a big round of applause for University of Pisa, flag 10. 10 problems. And they are awarded by a representative by Jane Street, Jackson Godley. So, okay, now I guess we are again in a situation where anyone solving one more problem, which I don't know, I still don't know if it will happen or not, they are getting first place, at least for now. So, now we have the story of PPP. They started super strong, like after, I guess, let me check. After 1 hour and a half, more or less, they had 8 problems. And then they got stuck for, I don't know, 2 hours or something. Then, just before the freeze, they managed to get some more solutions, which I guess, but I don't know, improved their mood. And now we can finally find out if they are the first ones getting 11 problems, which would now guarantee them the first place for now. But I think they could be easily overcome by one between ETH and École Normale Supérieure. So, Arbor Space, winners of last year's of work, are they winners of, can they be winners of this year too? Let's find out. 7 minutes till the end. Yes! Woo! Congratulations. So, now it really comes up to penalty time, and provided that someone else is solving 11 problems, which I have no idea about. So, we have École Normale Supérieure, which is, as I've already said, usually performing pretty well. I don't know if the 3 teams, they know each other's results. I don't know if they've shared what they've done, but they have no idea. So, École Normale Supérieure, solving this problem, I'm not sure they would guarantee them, maybe it would guarantee them first place. It's unclear. For sure it would guarantee them a gold medal. So here we are choosing if École Normale Supérieure is getting a gold medal or it's getting a silver medal. 11 minutes before the end of the contest. Problem I, and École Normale Supérieure is getting accepted. Congratulations. For those who can compute, I think you know already who's the winner of SWERC this year. So, but in any case, we are still choosing, I think we are still choosing who's getting a silver medal and who's getting the gold medal. Because I'm not able to do the computation now, but it might be that ETH is getting a gold medal if they're solving this one. 1 minute before the end. I'm not too optimistic. And for submissions, are they getting a gold medal? Yes! Congrats. So, finally, the first team with 11 problems, solving many problems as the first solve. Please, a big round of applause for Arbor Space on stage. They are awarded by Nicola Gugole from Bending Spoons. You can stop there, yes.
Nado?
Thank you very much. And so it turns out that second place, ETH Zurich, is not here because they had to catch a train. So we'll show the photo and we'll do a big round of applause for them, and that's it. They have already received their medals, their prizes, and their congratulations. Okay, and finally, I'd like to call on stage Dario, the director, because now we are giving the top prize and the only gold medal we are awarding on stage today to École Normale Supérieure. They had an amazing performance, solving 11 problems, very consistent. Congratulations to them. Please, a big round of applause for the winners of this year.
They've stolen my microphone. Another round of applause. Okay. Let's get down to business. So we saw, is there any way that I can get the ranking? No way. Spacebar? Okay, perfect. So, ENS, Ulm 1, and Paris, won SWERC 2022-2023. Another round of applause for them. Okay, and now the big question for the top teams. How many will advance to the World Finals? Since I do not know the answer, we'll do it like this. I start saying 1, 2, 3, and I wait for a nod of approval from Boba. When I stop having nods, I will tell you. Will at least one team go? Yes. Will at least 2 teams go? Will at least 3 teams go? So 3? I want at least 5. At least 5. We'll see how many of you I will see in Egypt in November for the World Finals. So, I think this pretty much concludes these, let's say, 2 editions of SWERC in Milan. I would like to call on stage 2 people that prepared a speech without me knowing, and I didn't have time to prepare. So please welcome to the stage Federico Glaudo and Edoardo Morassuto. I was, as I said, I was not trained to do this job. I hope I did good enough. But I can tell you that I couldn't have found 2 more capable people for these roles than these 2. So please give them a big round of applause. So with this, I say to you good night, good return to your homes. I hope to see you next year, but as a coach. And we'll see where the wind goes as far as the next SWERC edition host. And thank you. Remember, everyone that got a prize, everyone that got a medal, you also have a prize from JetBrains. Please go to their stand to get your prize. Thank you.
May I ask all the volunteers to come on stage for a group photo? Volunteers, technical staff, judges, organizing team, photographer, artist, everyone involved in the organization, come on stage for a group photo, please.